the same age, they were from the same breeder, and we separated them into 3 different houses having the same conditions. Each house had 10,000 birds, female, and 1,000 males in a ratio of 1 to 10. And all the houses had a controlled temperature which was ranging between 24 degrees to 30 degrees. Humidity was between 60 to 70%, and light was 20 lux. Light was regulated up to the point when they finished. From the start of lay, the amount of light is high. We go up to 22 hours of light, and then we start reducing the light downwards as the birds grow. When they're about 8 weeks, they go to 12 hours of light. Then when they start laying, we start increasing the light each day by 30 minutes up to when the birds are at the peak. And then they'll have the total hours of light would be up to 16. To measure the light, different bulbs are put which have a different amount of lux which is wanted for the birds to be able to see what they are eating. They were all given the same food, and they were always treated the same. When one house has a problem, they will all be treated. So this is exactly what I've been talking about. These are the birds when they were young. This is the house showing the light, the different heaters, then the feeding equipment, the water equipment, the nipple drinkers, and then the sawdust down. So when the birds grew, we introduced laying nests, and their feeders are all present here. Now, when the birds grow, we feed them in the morning at 6, and at 7 we raise the feeders up. You can see the feeders are in air so that they can all go and start eating. So basically that is what we do until now. They've started laying. My partner will continue with the next part.
Thank you, Ricky, for that wonderful presentation. I'll carry on from where you stopped. So these are the results, and here we have a picture of the eggs in the storage room. The ideal storage temperature is 19 degrees Celsius, and the results are graphically presented. As you can see here, we have the 3 treatment groups, all graphs supposed on each other, and we can see that the trend is similar, with a few differences which are almost minor, but generally that's the trend we have. So this is the graph from which we got the average for all the treatment groups. The 3 treatment groups gave us that average, and still we see that we have a similar trend to the 3, but now we are looking at the standard graph which we got from the literature for comparison. Now, this comparison gives us 3 things that we can look at. The peak. In our treatment group, we have the chicken peaking earlier than in the graph we obtained from the literature. In the treatment group, the birds peaked at 28 weeks. Yes, about 28 weeks. And in the standard graph from the literature, the chicken peaked later at around 30 weeks. But generally the trend is the same.
It is amazing. Look at this. This is a beautiful example. They look at the literature and they look at their result from their experiment, and you see it's like the literature. They actually find the same trend and the same result as the literature shows. It's very nice.
The other thing we can obtain from these graphs is the chicken in the treatment group started laying earlier at around 23 weeks.
Yeah.
And here we have the chicken starting to lay at 25 weeks.
That's
Maybe
nice
that
too.
explains the peaking, the earlier peaking.
And they also remained at the peak for a longer time than in the standard graph.
From where this data is coming from? From where? Which is
The source, the Agriyouth parent stock production manual. That's the book.
Okay.
It's the standard book for that strain of chicken. So in the discussion, now we're discussing the results. We largely agree with the literature, because our hypothesis, as we stated it, it says that the age affects egg production, and indeed we see that it's the case here. So the trend, as given in the graph, we see that the reduction in egg production was mainly due to fat deposition when the chicken grow, and this reduces on ovulation. Secondly, the feed conversion ratio reduces with age, and we very much know that the feed's the one which is going into the egg. So if we have a lesser feed conversion ratio, we have fewer eggs. That's with age. However, when they are still young, the egg numbers are increasing mainly because there's a low fat deposition, so we're having more ovulation, and the chicken are also young and they are converting the feed faster into production. That's the egg. The old birds, the chicken, also lay fewer eggs because of the lesser activity of the shell gland. It's synthesizing less calcium to calcify the egg, so it's reducing on the egg production. So that's the discussion. Conclusion. So we concluded that age affects egg production, and the average egg production peaks at 28 to 29, as we've seen from the graph. And this is basically from the graph. So we recommend that future research be done to ascertain how fertility affects the egg size. And farmers can use chart projection to look for markets in adults. That's if the eggs are for eating for the market.